Alright, this is part 2 of section 5.4 dealing with exponential functions. There's only 2 examples in this video. It should go pretty straightforward, and they're just going to be dealing with integrals. So going back to the formula, the antiderivative of e to the u is very simple. It's itself e to the u. Alright, so we're just going to use integration techniques that we've learned so far and apply them to this. So I see that I have something inside the exponent of e, so my first thought would be to do a u sub. We can go ahead and try to do a u sub for this integral. So u is going to equal negative x squared. The derivative now is going to be negative 2x dx. I do have an x and dx in the other part of the problem, so I know I'm on the right track. Don't have this extra negative 2, so I'm going to divide this over. This is negative 1/2. Du is equal to x dx. And so my integral turns out to be e to the u. I'm able to replace x and dx with negative 1/2 du. And I have to change my limits because I have a u sub with limits, so this 0 stays 0. Now when I plug in a 1, it becomes negative 1. This negative 1/2 factors out. And it's perfectly okay to have your limits be rearranged or not be in the correct order when you're doing a u sub, but only when you're doing a u sub. And I go ahead and simplify this some more. It's going to be negative 1/2. Antiderivative of e to the u is itself e to the u. And my lower limit is 0, upper limit is negative 1. I'm going to go ahead and put this negative 1/2 out in front and then plug in my limit, so e to the negative 1 minus e to the 0. And I can what I can do is I can distribute this negative 1/2 once I have this simplified. E to the 0 is going to be 1, so my answer is going to be negative 1/2e plus 1/2. Now, depending on what the answer is, if it's multiple choice on a test, it could be that you have to simplify this far. If it's free response, you might be able to just leave it like this. If it's in the back of the book, you might have to find common denominators between these two. So how much you simplify, again, is up to how far you have to simplify. So this could be acceptable. This also would have been acceptable under certain circumstances, like if it was free response. But like I said, how much do you simplify? Just as much as you need to. Alright? So last example is going to be find the integral to this. The general idea for u sub is whatever you decide to pick for u, the other part of the problem has to be the du part. So in this case, I have a square root with something inside. So my first idea is to let u be that part of the problem. So I let u equal whatever's inside the square root 1 plus e to the x, because the derivative of what I select has to be the other part of the problem, and the derivative of e is itself e to the x. And so I can simplify this. There's no need to multiply or divide by a constant. It's already pretty much set up for me. I can just put this as the square root of u. E to the x and dx are going to both get replaced with just du. And then I can write this for the power rule as u to the 1/2 du. I don't have to do a logarithm or anything like that because this has a power rule. So I can use this power rule as long as it's not negative 1. 1/2 is obviously not negative 1, so I can just say add the power by 1, so 1/2 plus 1 is 3/2. I reciprocate the power. I have to flip it. I have to reciprocate it, so it's going to be 2/3. I don't have any limits, so I go ahead and put the plus c. And then go back to what I initially selected for u, which was 1 plus e to the x, so it's going to be 2/3 parentheses 1 plus e to the x, all raised to the 3/2 plus c. And that's my answer. And that's all for part 2.